Welcome to ChemDoodle Shorts. I'm Mary, your ChemDoodle Pro. Let's learn some tips and tricks when assigning RNS configurations. You've learned the basics of determining absolute configuration of a molecule by designating it as R or S. First, assign KIP priorities to the atoms bonded to the chiral center. The atom with a higher atomic number has priority. Bromine has the highest atomic number, 35, so it has priority 1. Next is chlorine at priority 2. And then fluorine at priority 3. Last, hydrogen has the lowest atomic number, 1, so it has priority 4. With the lowest priority group, the hydrogen, oriented away from us, draw an arc from priority group 1 to 2 to 3. When the arrow direction is clockwise, the stereocenter is R. When the arrow direction is counterclockwise, the stereocenter is S. Assigning a chiral center as R or S is straightforward when the molecule is presented with the lowest priority group already directed away from us. But what do you do when the lowest priority group isn't oriented away? Let's see what to do when the lowest priority group is pointing toward you. In this molecule, the lowest priority group is the hydrogen. If the lowest priority group is coming out of the plane of the screen, you can simply flip the molecule over. To better visualize this, let's see the molecule in 3D. Flipping the molecule over orients the lowest priority group, the hydrogen, away from us. Now it's easy to determine the absolute configuration of the chiral center. Iodine has the highest atomic number, 53, so it's priority 1. Fluorine has the next highest atomic number of 9, so it's priority 2. Then comes oxygen with an atomic number of 8 at priority 3. Last is hydrogen. Drawing an arc from priority group 1 to 2 to 3, the arrow direction is clockwise. To resolve absolute configuration in ChemDoodle, select the molecule, then select the structure menu, stereochemistry, and assign RS KIP. This stereocenter is R, because these two molecules are the same, just flipped. The original drawing is also R. When the lowest priority group is directed toward us out of the plane of the screen, we can flip a molecule over to determine absolute configuration. However, flipping a molecule can be challenging to picture without a 3D model, and with more complicated molecules, such as morphine, with 5 chiral centers, flipping the molecule becomes impractical. So here's a trick to easily determine the absolute configuration of a stereocenter when the lowest priority group is oriented toward us. Simply determine the absolute configuration of the stereocenter, and then change it to the opposite. Looking at the original molecule, let's assign KIP priorities. Now, let's draw an arc from priority group 1 to 2 to 3. The arrow direction is counterclockwise, which means S. But remember that the lowest priority group is oriented toward us, so we switch the configuration to the opposite, R. Matching what we determined previously. What if the lowest priority group is neither oriented toward us nor away from us, but rather is positioned in the plane of the screen? Here, the lowest priority group is the hydrogen, and it's in the plane of the screen. To easily determine absolute configuration in this case, swap any two groups of the chiral center, determine the absolute configuration of the new molecule, and then reverse the absolute configuration. To start, let's switch the fluorine and the hydrogen. This puts the hydrogen, the lowest priority group, in the back, pointing away from us. Take note that swapping any two groups creates a new molecule. Although similar, these two molecules are different. They are not the same. Then, assign KIP priorities. Bromine has the highest atomic number of 35, so it's priority 1. Next is chlorine, then fluorine, and finally hydrogen. With hydrogen, the lowest priority group positioned away from us into the plane of the screen, determine the absolute configuration of the stereocenter. From priority group 1 to 2 to 3, the arrow direction is clockwise. So this stereocenter is R. Be mindful that swapping any two groups on a chiral center reverses the absolute configuration. To resolve the absolute configuration of the original molecule, simply invert the absolute configuration of the new molecule. R would become S, and S would become R. The new molecule is the R enantiomer, which means that the original molecule is the S enantiomer. There are some convenient tips to determine absolute configuration when the lowest priority group is not positioned away from us into the plane of the screen. When the lowest priority group is pointing out of the plane of the screen, oriented toward us, simply determine the absolute configuration and reverse it. R becomes S, and S becomes R. When the lowest priority group is positioned in the plane of the screen, swap any two groups of the chiral center. Determine the absolute configuration of the new molecule, and then reverse it. R becomes S, and S becomes R. These useful tips and tricks are handy when you don't have a model to help visualize, and can also save you time. Thanks for watching ChemDoodle Shorts.